Hi students, very good morning to all of you. Today's class we are going to discuss Curie temperature and temperature effect on permanent magnet materials. The last class we discussed about the minor hysteresis loop and recoil line. So for many practical application, for example, designing of motor, generator, we are not considering major hysteresis loop. We consider only minor hysteresis loop while designing of motor and generators. So now we will discuss what is the temperature of the permanent magnet material, what are the effect of the permanent magnet material, we are going to discuss in this class. We already discussed 4 types of magnetic materials. The first one is all-nickel magnet, we know that very well. First one is all-nickel magnet. First one is all-nickel magnet. The second one is ceramic magnet. And the third one is SMCO magnet. And the fourth one is called as NDFEB magnet. So we have the 4 types of permanent magnet materials. We already studied applications of permanent magnet material and also discussed hysteresis loop of permanent magnet material and recoil line and the minor hysteresis loop also we discussed in the previous classes. Now we will discuss Curie temperature. We will discuss Curie temperature. What is the Curie temperature? The Curie temperature is defined as a temperature above which ferromagnetic material behaves like paramagnetic materials. So what is the Curie temperature? The Curie temperature is a temperature above which the ferromagnetic materials behave like paramagnetic materials. Paramagnetic materials. So we have 4 types of permanent magnet materials. First one is all-nickel. We already discussed. The second one is ceramic magnet. Third one is Sumeri cobalt, and the fourth one is NDFE magnet. Okay, so the Curie temperature of the all-nickel magnet is 890 degrees Celsius. The Curie temperature of ceramic magnet is 450 degrees Celsius. The Curie temperature of SMCO is 700 degrees Celsius. The Curie temperature of NDFE magnet is 350 degrees Celsius. Okay, so what is the effect of Curie temperature? So before this temperature, the magnet acting as magnet above this temperature, this magnet is behave like paramagnet. Paramagnet means it is lost their magnetic property. It is lost their magnetic property. So see here, metallurgical changes take place from, suppose we consider all-nickel magnet. The Curie temperature of all-nickel magnet is 890 degrees Celsius. But it changes behavior from 550 degrees Celsius onwards. For example, this is one magnet. This is a permanent magnet. Okay, so this is north pole of the magnet. This is south pole of the magnet. Okay, this magnet having dipoles. This is a dipoles. That's the direction of the dipole of the magnet. Example. Now, the operating temperature, the temperature of the all-nickel magnet is about, for example, 400 degrees Celsius. See here, very very important. This direction of magnet, dipole of the magnet may align in the different way, small like this. So now see like this same. Up to 550 degrees Celsius, there is no change in the direction of magnet dipole. The above 550 degrees Celsius, the direction of magnetic dipoles may align the property like this. May align like this. Okay, after 890 degrees Celsius, the magnet dipoles completely realigned like this. It is not follow some path. This follows some other path. So this type of property is called as ferromagnetic material. So ferromagnetic material means the permanent magnet lose their magnetic property. So next one is ceramic magnet. The Curie temperature of ceramic magnet is 450 degrees Celsius. So there is no metallic change take place from. As a smiling cobalt, from 350 degrees Celsius onwards, the behavior will change. NdFe magnet also, the behavior is starting from 200 degrees Celsius. See here, above the Curie temperature, the permanent magnet material lost the magnetic properties. Clear? So above the Curie temperature, the permanent magnet materials lost their magnetic property. So above the Curie temperature, the magnetic material does not act as a magnet. It is simple iron phase. Okay. So see here, the temperature is increased towards the Curie point. The alignment within each domain decreases. Already we discussed. See here. So this is a dipole alignment below the Curie point. So this is a magnet dipole alignment of above the Curie point. See here, this is a magnet dipole. This is a magnet dipole of the permanent magnet material. See here. So this is the orientation of magnet dipoles. So this magnetic material is subjected to above Curie temperature. Above Curie temperature C, above this value. So what happens? See, this above Curie temperature, what happens? See, these magnet dipoles aligned in different ways, like this aligned. Okay. So in this condition is called as ferromagnet. So the above the Curie point, the material is purely ferromagnet, and there are no magnetized domain in aligned movements. So next one, temperature effect. What are the changes on the permanent magnet material due to the temperatures? Okay, so temperature is playing important role in the permanent magnet applications. We'll see there are three types of losses. The first loss is reversible losses. The first loss is called as reversible losses. So this type of losses, once loss occur, after some time, it will recoverable. It will regain automatically. The second one is irreversible losses. These losses, once losses occur, we cannot recover. The third losses is called as irreversible losses, but recoverable losses. But this type of losses is called as partially demagnetization of magnetic material. Once these losses occur, after it is possible to remagnetize. After some time, it is possible to remagnetize. Okay, with help of some process. So the first one is reversible losses. What is the reversible losses? The reversible losses occur every degree rise in temperature. Every degree rise in temperature. Okay, these losses occur, suppose it is a magnetic material, this magnetic material subjected to some temperature. So every rise in temperature, some losses are occurring in the magnetic material itself. So these magnetic losses will occur above ambient level up to maximum operating temperature only. It is occur only above ambient level and it is maximum operating temperature. Maximum operating temperature. So the magnet subjected into the maximum operating temperature. Okay. So as magnet is cooled after some time, the performance return to the original level. Okay. For see here, this is a magnet. This magnet is subjected into temperature. The temperature is above ambient level to it is maximum operating level, operating temperature. Okay, after some time, what happens? See, after some time, this magnetic material cooled. Okay, again, we will check the property of the magnet whether it is regained or not. It is do not lose the property. Do not lose the property. This type of loss is called as reversible losses. Once loss occur, it will regain automatically. Okay, this type of loss is called as reversible losses. But here very important, we can heat up the material up to maximum operating temperature of particular permanent magnet material. That is very important. So next one is irreversible losses. Already we discussed what is irreversible losses. So irreversible losses, we cannot recover all original property. That means when the magnet is heated above it is maximum operating temperature. The previous case, the magnet is heated up to it is maximum operating temperature. But here you see the above operating temperature. This is very important. The magnetic material is heated above maximum operating temperature, but below Curie point. This is very important. But below the Curie point, it will experience irreversible losses in the performance. Clear? So this means if magnet is cooled, after some time the magnet is cooled, its performance will be weaker than it was before it was heated. Okay, so we cannot recover all original magnetic property. The magnetic property weaker before it was heated. Okay. So this is called as irreversible losses. So it is remagnetized back to its original strength, but it is not cost-effective process. So it is possible to remagnetize. It is possible to remagnetize to the original strength, but even though it will take more cost for this remagnetization process. The irreversible losses happen just once. It will occur just once. Suppose the same thermal cycle is repeated, no additional losses will be occur. Okay. So generally irreversible losses only one time is occur. Okay. So if heated again, it cannot occur. There is no additional power losses will occur in the magnetic materials. This is very important. So temperature of reversible losses, there are four main parameters. First one is temperature. First one is temperature. Temperature of magnetic material. Second one is time at temperature. Time at temperature. Third one is self-demagnetization or load line. Load line of permanent magnet materials. The next one is any applied adverse magnetic field. Adverse any magnetic field. So irreversible losses depends on these four parameters. Okay. So next one is loss is irreversible losses but recoverable losses. Irreversible losses, it is recoverable losses. This type of process is also called as partially demagnetization. Partially demagnetization. So completely demagnetization means we cannot recover the original strength of the magnetic material, but partially demagnetization means it is possible to remagnetize of this magnetic strength of the magnetic materials. Okay, so these losses are defined as partially demagnetization of the magnet from exposure to some temperature. The temperature may be low temperature or high temperature. Are you clear? So the magnetic material is subjected into some temperature. The temperature may be high temperature or low temperature. High temperatures or low temperatures. So these losses are only recoverable by remagnetization and not regained automatically. So we need to develop the process for recoverable of the magnetic strength. It is not automatically remagnetized. That is very, very important. So it will take some cost. Okay. So when magnetic temperature returns to the normal level, normal strength. Next one, when designing an application of permanent magnet, it is essential to consider temperature range that magnet or magnets will be expected working. So this means, so we are going to consider for any applications by using the magnetic material, we consider operating temperature of particular application. Operating temperature particular application, it is very, very essential part. Then only we can select the permanent magnet material for particular applications. All the magnet material experience changes flux density, the temperature increases or decreases from ambient temperatures. So we have the flux density. We have flux density and the magnetizing force. This flux density may increases or decreases, depends on the temperature, increases and decreases. Depends on the temperature, the property of the temperature. So, okay. So sometimes some magnetic material temperature increases, flux density or decreases, like that. So we have the property of the flux density depends on the operating temperature. Operating temperature from the ambient temperature. This is very, very important. So next one, we discuss what are the losses in the magnetic material. Now we will discuss what are the effect on temperature of particular magnet. First we will see temperature effect on Alnico magnet. Temperature effect on Alnico magnet. Alnico magnet are characterized by higher retentive force but lower value of coercive force. See here, we already discussed the previous class. This is a B flux density of the magnetic material. This is H of magnetic material, the magnetic force. This is your Alnico magnet. This is the value of the BR. This is the value of HC. Coercive force, retentive flux density. This is very high value, this is very low value. So that it is highest thermal stability. So this material, that Alnico metal, Alnico having highest thermal stability and lose only 0.02% of performance every rising temperature. For example, temperature of 25 degrees Celsius. Now, temperature increases to 25 degrees Celsius to 26 degrees Celsius. The lose the performance only 0.02% per degree Celsius. So among our permanent magnet, it has highest operating temperature. Highest operating temperature. The next one magnet is called a ceramic magnet. So what are the effect of ceramic magnet? Due to the temperature The ceramic magnet can be used in temperature up to 180 degrees Celsius. Can be used up to 180 degrees Celsius. Now before they will start experience irreversible losses in the performance. Okay, so now this means the operating temperature of the ceramic magnet is 180 degree. Okay, so it can be used up to 180 degree, but the irreversible losses will occur before 180 degree. Irreversible losses will occur before 180 degrees Celsius. Okay, so this is very, very important. This type of magnets are popular, higher value of the temperature, higher operating temperature, so that this type of magnet highly used for in the motor and the generators. Okay, so this type of magnetic materials are popular, so that it is operating higher temperature. So hence, so this type of magnet is suitable for motor and generator applications. So next one is called as SMCO, Summery Bobart. It is a standard grade of Summery Bobart. This is standard grade. Magnet will not suffer reversible losses or recoverable losses until temperature exceeds 350 degrees Celsius. So there is no losses will occur up to 350 degrees Celsius. Up to 350 degrees Celsius, there is no losses will occur. So beyond that value may occur losses. That is very, very important. Next, here both retentive flux density and coercive force highest value. So it is not strong magnetic material as compared to the NdFeB magnet. Okay, so it is not a strong magnetic material as compared to this one. Okay, but both value, both Br and Hc value, see here the Br value also more, retentive force, Hc also value also more. So next magnet is called as NdFeB. NdFeB means neodymium, iron and boron. It is alloy of neodymium, iron and borons. So this is a change in the degree change in performance for NdFeB magnet depends on the shape and applications. Depends on the shape and applications. So here also this magnet also having very high value of Br and Hc. Br and Hc. It is the strongest magnetic material among these all magnetic materials. In fact, depending on the size, shape, grade, and how it is used, the neodymium magnet will lose 0.08 to rise in temperature. Every rise in temperature. So based on the depends on the size, shape, and the grade and usage. It will lose their magnetic properties from 0.08% to 0.012% for every rise in degree Celsius. The standard grade of neodymium magnet have maximum operating temperature is about 80 degrees Celsius. 80 degrees Celsius. When heated above this, they will experience irrecoverable losses in their performance. Okay, see here, this magnet up to 80 degree, there is no problem. So beyond that value, what happened? So the losses occur in the magnetic material. That is irrecoverable losses. That means losses once occur, we cannot recoverable. That is the irrecoverable losses. Next one is summary. Summary of this class. First one we discussed the different types of permanent magnet materials. Okay, next one's discussed Curie temperature. Above which temperature ferromagnetic ferromagnetic materials lost their magnetic properties and at these conditions the magnet dipoles are completely disappears and also studied a different temperature range of different temperature range of PM materials, permanent magnet materials, and also discussed temperature effects on permanent magnet materials. So we have discussed 4 magnetic materials with the temperature effect. First one is alnico, second one is ceramic, third one is SmCO, and the fourth one is called as neodymium, iron and boron. So these are the 4 magnetic materials. We already studied the 4 magnetic materials and Curie temperature, operating temperature. What are the losses? We studied 4 types of losses. One is 3 types of losses we studied: reversible loss, irreversible loss, and reversible loss but recoverable. So we have studied all these important points in this class. The next class we will see how to handle the permanent magnet materials, and the properties of permanent magnet materials. Thank you.